Now in this video, I'm going to explain you the default setup which I'm going to use for most of my CCNP route labs. Okay, so for most of the labs, first we need to understand the default topology. It's just like, when you're going through with this course, probably you need to understand this is my lab setup, or maybe you can assume that this is your company network where you are trying to implement some of the new technologies, and that's what we are going to assume for the next all the topics here. Now I'm going to use some very simplified way of doing the things by adding as less number of routers as I can to verify the each and every technology. Now I documented I designed one lab with 4 routers. You can see router 1, router 2, router 3, router 4. They all are connected to each other. So the router 1 is connecting to router 2 via back-to-back cable, router 2 to 3, 3 to 4, and 4 to 1 back again. Now I'm using some serial interfaces, and mostly I'm using S1 by 0 interfaces here as per my topology. You can see here S1 by 0 going to S1 by 0, and then S1 by 1 is connecting to the other side, and then again to 0 and then 1, something like this. So mostly I'm using serial interfaces on back-to-back cable. Now if you want, you can also use Ethernet cables for these connections, and I'm not going to use that. So whenever you try to understand, try to do any configurations in the lab, you need to know what is the exact port going to router 1 to 2, router 1 to 4 here. And on the WAN interfaces, again here, for all my LAN interfaces, I'm going to use my 10.1 network, 10.1.1.1, and on the, let me just write down here. So on the router 1, router 2, router 3, router 4, I got some LAN interfaces, and all the LAN interfaces I'm using F0 by 0 interfaces, which I'm going to assume that it is connecting to my switch, and then on the switch I got some computers here. I don't have real computers connected here, but we are going to assume that the router is connecting to the LAN. And we are going to use 10.1.1.1, 20.1.1.1, 30.1.1.1, and 40.1.1.1. Now the 10, 20, 30, 40 simplifies like router 1, router 2, router 3, router 4. Now this is the default addressing I'm going to use in the LAN interfaces, where it makes a little bit easier for us to remember, like 30 represents router 3, 40 represents router 1, like that. These are the LAN interfaces we are going to use for the LAN interfaces. And everywhere I'm using default subnet mask just to simplify the things. But I'm not using any subnets. Probably you can also add subnets if you want in the later on sessions to get into some kind of designing based on the slash values or based on the requirement. Now the next thing, on the WAN, I'm going to use 1.1.1.1. On the WAN, I'm using 1. network, on 2. network, 3. network, and 4. network. Like mostly I'm using 1.1.1.1, 1.1.1.2. You can see here on the router 1 to 2 WAN interface, I'm using 1. network. Router 2 to 3, I'm using 2. network. Router 3 to 4, I'm using 3. network and 4. network. And mostly it will be 1.1.1.1 and 1.1.1.2, 2.2.2.1, 2.2.2.2. You can see here 3.3.3.1 and 4.4.4.1. So the 1. network we are using on the WAN interfaces, and here also I'm using /8 subnet mask, the default, but in the production network you may find /30. That's something recommended based on the subnetting. Now connecting between the routers. Now these are the LAN and the WAN interfaces, and apart from that I'm also using some loopback interfaces here. Now the loopback interfaces are the logical interfaces I'm using to simulate the labs. Now in CCNP we are going to assume that we got a very big network, and we are going to simulate a bigger networks, like assuming that I got a router, 4 branch offices connected here, and assuming that I got some 4 different LANs set up here on each and every router. Now instead of connecting 4 different networks or 4 different physical interfaces, I'm going to simulate this by using some of the logical interfaces here. Now the difference between the physical and the logical interface is, in the physical interfaces we are going to provide a connection. Maybe it is connecting to the LAN or the WAN interfaces, or to some routers, or to switch, like that, and we are going to assign the IP address. And we can do some testing like ping kind of things. But the difference is the logical interfaces, or we can also call as loopback interfaces. Now in terms of loopback interfaces, we are not going to do any connection. There is no connection here. It's just an interface which is logically no connection, but you can still use them for ping testing, or we can trace them. We can also advertise them as if we have some kind of networks present here. Now this is the best way to simulate some extra networks here, assuming that we got some extra branch offices connected on the router 1. Similar way, I'm going to assume that there are 4 different branches connecting to router 4, 4 different branches here. Now this way we can make our routing table more bigger, and we can assume that as if we have some more networks connected. We can build some bigger routing tables, and we can optimize it in a more better way, like assuming that we have some very big networks. And that's the reason I'm adding some loopback interfaces here. But in the real scenarios, this is something not really mandatory. In the real scenarios, you may have some real branches, maybe a real routers connected in the LAN, and you might be using these networks on the branches here. So here I don't want to make my topology much bigger. I don't want to add some additional routers, like adding 4 routers everywhere. It's going to make almost 20 routers, and that's something I cannot do it. I don't want to do it as well. So that's the reason I'm adding some loopback interfaces. So I hope we got the idea of the loopback here. Loopback are just logical interfaces here. Now the next thing, what I'm going to do is here, the initial configuration. Now initial configuration is almost like the basic CCNA for you. Like this is something I have documented already in the workbook. Like on the router 1, we got 2 interfaces. Like we know how to configure the IP addresses. Changing the host name if it is not R1. I use the names as R1, R2, R3, R4. And on the router 1, I'm going to add a command called no IP domain lookup. Now no IP domain lookup is a very useful command, especially whenever you are typing any wrong command. Let's take an example. I'll get into the command line of any one of the packet tracer program here, or any other router command line. So let's take one router here. Let me take one router here, and let's go to the command line. Now normally whenever you type any wrong command, what happens is it's going to do something called translating that, something like that. It's going to send a broadcast request to all the routers, assuming that whenever you type any wrong command, let's say I want to type configure terminal, maybe by mistake we did some spelling mistake, and when you type it, normally it goes into this translating mode where it is trying to resolve the host name to IP address. That's what DNS lookup, and this is something I really don't want whenever we do typing. Normally to skip this, we need to use Ctrl+Shift+6 button to abort this one. But every time when you type any wrong command, typing Ctrl+Shift+6, in the real devices it's going to take some time, even though you press Ctrl+Shift+6. And that is something I really don't want. Now we can disable this lookup by giving this command called no IP domain lookup. Now whenever I go to the config mode, when I say no IP domain lookup, it's going to simply disable lookup. Is it no IP domain? I got a wrong spelling here. Domain lookup. Now once you disable this, whenever you type any wrong command, it will simply say it's a unknown command, but it's not going to translate like this. That's something recommended. Initial configuration I generally do in my lab setup, because in my lab setup we are not using any DNS resolution, something like that. So if you are using, then please don't do this, don't disable that one. Now the next thing, we are going to type the interface IP address. Now you know how to assign the IP address on the LAN interface here, 10.1.1.1, and then no shutdown command. And then there is one more command called no keep alive. Now this command is strictly, it's a lab scenario command, don't use in the real networks. Even the no IP domain lookup also, if you don't have DNS, you can disable it. Now the major difference is, like generally if you take a normal scenario, if you have a switch connecting to a computer, now on the computer screen generally you will see the message as local area unplugged. Now whenever you remove the cable, or if you power off the switch, or there is some problem with the port, or you remove the cable on the other side, you will see local area unplugged. Now, why it comes? Because by default there is something called keep alarm mechanism between these two devices. By default they do send keep alarm messages. Now these keep alarm messages are sent for every 10 seconds between these two devices, which is going to confirm that whether the connectivity is there or not. Now the same thing happens when you're connecting any two networking devices, like maybe a switch to router, or maybe, but on the routers you'll see swipe interface brief commands. So default there is a keep alarm mechanism. Now in my lab scenario, probably I'm not connecting any switch here. In the real scenario you have a switch connecting here, and then you have some computers connected here probably. Now I don't want to connect any switch here. That's the reason what I'm doing is, in my lab scenario I'm going to disable the keep alarm messages here, saying that even though there is no connection, still make the interface up. Because by default if the interface is not connected, in that case it will show as down, and that is something I don't want. And remember, this command is again applicable only in the lab scenarios, because in the real scenario if you disable this keep alarm, even though you remove the cable, still it will show as up, and that is something we really don't want in the real networks. And it's a strictly a lab command. If you are connecting to a switch in that case, or to computer, probably you don't need. But if I want to make this interface up, I need 4 different computers to connect it, or 4 different switches, and that is something I'm not doing in my lab setup, and that's the reason I'm using no keep alarm. And even it's something not possible for you to set up with 4 different computers or 4 different switches. Even I don't want to waste my computers just for connection. So that's the reason I'm using this command. And on the serial interfaces, probably we just need to go into interface and assign the IP addresses. And if you're using back-to-back cable, don't forget to add the clock rate commands on the DC side. And this is something you know from the basic CCNA classes. And to create the loopback interface, we just need to go to the interface loopback 0. The command is very simple. We can simply say interface loopback 0, loopback 1, loopback 2, like that. You can create a very big range of loopbacks. Like I can go to config mode and I can say interface loopback. You can see the range of loopback interfaces I can create. Now in my lab scenarios, I'm going to use loopback 0, 1, 2, 3, and the IP addresses as per the diagram 11.0.01, and then 1.1, and then 2.1, 3.1. Now, and you don't need to give no shutdown command, because the loopback interfaces will be by default up. No need to give. You can still make them down by using shutdown commands, but by default they are up. So if you just get back to the topology here, I got 10 dot network which is used in my LAN, 1, 2, 3, 4 used in the WAN, and then 11, 12, 13, 14 I'm using on the as a loopback interfaces. Now again 11 dot on the router 1, 12 on the router 2, 13 and 14 on the router 3 and router 4. So the configuration, this is what I'm going to use in my lab setup. Probably if you go through with my CCNP or CCI basic labs, I'm going to use this setup for most of my labs. All the advanced labs I'm going to set up on this topology. Now depending upon the requirement, I may not use router 4, so probably the topology will be like this: R1 to R2, R2 to R3. So in some labs I'll be using all the 4 routers. In some labs I'll be using just router 1 and router 2, where I'm going to power off the remaining routers. And then I already saved the configurations, so that every time when I reboot or when I reload my devices, I want to ensure that these IP addresses should be pre-configured and it should be loaded automatically, so that I don't need to assign the IP addresses again and again every day. Probably this is something pre-configured in my labs, and I have saved the configurations. So the only thing we'll do routing, probably we'll keep on changing the routing configurations. When we do some EHRP labs, we do EHRP routing, OSPF routing, BGP routing, like that. The routings will change, but the IP addresses still remains the same. Now to set up these lab options, probably you can either use your dedicated rack, physical rack with the 4 routers. We're probably using 1800 or 2800 series routers, or any other series routers with the 4 routers with some back-to-back cables. Or you can set up these labs on the simulation tools by using some of the simulation softwares. Like Cisco Packet Tracer, it's very good tool for your CCNA level labs, but for CCNP routing especially, I don't recommend you to do that. If you're planning for any kind of simulation tools, you can use GNS3 is the alternative for most of the CCNP CCI level labs, which supports some of the high-end configurations like that, or you can use some online rack rentals to get into that. So probably in my next sections, I'm going to give some overview on the GNS3 program, which I'll be using for the labs, and how to set up or design the topologies into that. Probably in this section, we have seen some of the default lab scenario or the default lab setup I'm going to use, and the IP addressing part.